I'm Nicolai. I'm a Java developer advocate at Oracle, and today we're going to talk about Project Amber, the solution factory for Java's problems. So, Java's got problems. It's slow, it's old, it's verbose, it's cumbersome, it's just not fun, and none of that is true. But also, none of that is entirely false. There's some truths hidden in these overly general complaints. If you take a little bit more nuanced view, then some problems, and I'm sure there are more, could be these, right? So strings, for example, lack expressiveness. A type system and encapsulation can get in the way. For example, if you use something like TypeScript, where you can just not use types when you don't want to, that's sometimes kind of neat. Dealing with data is clunky, and getting started isn't that easy. And the solution factory to these and other problems is Project Amber. It's about right-sizing ceremony, which means ceremony that you need. Try to make that as small as possible where you need it, and maybe even go away in places where you don't really need it. The slides are online. I'll show you a link in a second. And everything green is a link to the project, the wiki, the mailing list. It launched a couple years ago and is led by Brian Getz. The goal is not code golf, meaning which feature can we add so that we can maybe save another line of code or another couple characters in this line. And it's also not to chuck every feature under the sun into Java. Instead, it is to identify those places where Java does lack expressiveness and try to turn its strengths, those places where its strengths turn into weaknesses, and try to find those and counter those situations. And wherever there's a tension or a trade-off within the language or within the ecosystem, within the API, try to resolve that. And this lens of a conflict between different things that we want, that is a lens through which you can actually view a bunch of other projects as well. Valhalla, for example, tries to take away almost entirely the trade-off between the design that I want and the performance that I want by allowing us to have both at the same time. Loom wants to take away the trade-off between simple code and scalable code. Panama wants to take away the trade-off between writing the flexibility of using off-heap memory and native functions, but still wanting to have the safety that comes with using systems on heap, and try to find a good middle ground there. And Leiden you could see as operating on the tension between optimizations and the specification that Java allows. But that's not what this is about. We're here to talk about Project Amber. We're specifically talking about strings, type safety and encapsulation, how to deal with data, and how to start with Java. And this is where you can find the slides. So when I say Project Amber, why are we talking about a project? What is that really, right? OpenJDK is a big community, and whenever a large problem is identified, a project is formed around that, like the ones that I just mentioned, and Amber is one of them. So that's what this is about. What we're discussing here are features that are already present, that are currently being previewed or developed, or something that may be just beyond the horizon that we get to see soon. So let's start with strings. Let's start with how Project Amber smartly enhances one of Java's most important and most fundamental types. So I give you a minute to look at the code. Not a minute, a couple seconds to look at the code. It's JSON, or it's supposed to be JSON. It doesn't look like it though. So what I'm trying to manage here is I'm trying to create a string that works. The language recognizes that and helps me. It's a string. Great, that part worked. I wanted to go multiple lines, and that already starts hurting, right? So I actually went through a lot of effort. I put a \n here and then also did an actual line break, and then I put \t here for the indentation. I tried to kind of mimic what it's supposed to look like, but it's not great, right? The language doesn't understand what I'm doing. I want indentation. Yeah, that's totally on me. I need quotation marks. So every double quotation mark I need to escape, which is great fun. It makes it super readable. And also I'm embedding variables, and this way it all falls apart. Literally, I have to end one string and start the next string and put something in between. And this is also open to injection if that's user-provided input. So it's clearly not great. And the reason for that is that a regular string literal just lacks expressiveness. It's a single line, no embedded variables, just everything that can be escaped kind of thing. And Project Amber is working on that. But it's delivering these features, the things that are lacking, not in one big thing. So you have the old stupid string and you have the new better string, but in different incremental steps that you can combine as you need. So let's start with text blocks. They were finalized in Java 15, and they are multiple line string literals. And they do something that is not very common for this feature in other languages. They do understand incidental versus essential indentation. What I mean by that is that the code here under string is indented, right? There's like a tab here. If you're an evil person, maybe it's 4 spaces. But anyway, so there's a tab here. So this part is just code indentation. And that's not present in the resulting string. But this tab here, that is present in the final string. I'm not going to talk you through how that works, but it does work, and very reliably, and that is great because Java here learns something from the mistakes of other languages and delivers a similar feature in what I think just a better way. And also, somewhat accidentally, it requires less escaping because the single single quotation mark is no longer a special character. It's not the single quotation mark, it's a single double quotation mark character is no longer special because we need 3 double quotation mark characters to end the string, and also you don't need \n anymore, so there are less escape sequences, which is good. But what this feature gives us on a higher level is we can basically turn on multi-lineness. We can say, okay, this is a regular string, this is a string that needs multi-lineness, so I just use a text block. If you want to embed variables, it's not going too great though. So this is, I think, the best way to embed variables in a text block, which is to use the formatted method, which is like string.format, but it's not static. So you can call it after the text block, and then you pass in the variables, and this uses the regular string formatting syntax, which is %s for string and %d for number, like double, I think it stands for. Who knows? So this is a okay way to do it, but it's not great. And Java 21 now previews string templates. They allow us to embed expressions, preferably small ones, but technically you can embed a whole lot there, like full method calls and whatever. Can put a whole stream pipeline in there, but I would recommend not to. So you can embed expressions like here, where this is a reference to the variable name, and this is a reference to the variable bday. You can put them here. But they do need explicit processing. This str thing here needs to be there, something like that. Not necessarily str, but something needs to be there. And we can now enable variable embedding. So this is a preview feature in Java 21. It's quite new. Let's have a closer look. The template expression, or the string template, consists of 2 parts. The template expression itself, which is, in this case, a multi-line string, but it doesn't have to be, works with the string literal as well, which has embedded expressions or variables. That's called the string template. And then you have this str thingy in this case, which is the template processor, which takes the string template and turns it into a string. Note the little asterisk down there. That becomes important later. By the way, I did have a beer for lunch, but it's not, the movement is not because I'm drunk, it's because there's a delay on the screen. Trust me. So if I don't point at the exact right thing, I claim innocence. Okay, so why are we talking about strings though? So what you often do is you create a string not for another person to read, but for another system to process. And what frequently happens is that you start with something that's a part string and part the variables you want to embed. And if you want to make sure that that thing does not suffer from SQL injection attacks or from, whether it has the right formatting, that it has escaping, that all of those rules apply, you would validate, sanitize it, but that would require parsing it. And once you've done that, you often get back a string. You now know that it's a perfect string, it's actual real JSON without any problems, but you dumbed it back down from the parsed entity to a string, and if you then pass it on to a system that needs to parse it again in the same VM, that's just wasted work. So why the detour? And the answer is no reason, actually. So this is what str is. str is a singleton instance of an implementation of this interface. And this str dot syntax is just some sugar, so it's shorter for us to write. And as you can see here, the implementation of processor has as a generic argument not only the exception that it can throw, but also a result. And process can return that result of any type. So there's actually zero reason to turn SQL or JSON into a string. This processor can just return a rich domain object. So for example, a library like Jackson could implement a JSON text processor, JSON string processor. Then it would offer a static instance somewhere called JSON, and I would just import that here, and then I can write JSON dot, and then I write the thing there that looks like JSON, and what I get back doesn't have to be a string. Could be a JSON object. That means it's validated, it's sanitized, it's parsed, and it's ready to be processed further. And if I do need the string, I don't know, I can call to string on it, or maybe I get a second template processor that then turns into a string. But the point is, these things can give me back actual domain objects, which is huge, right? So for example, I can use this with SQL statements without worry about injection attacks. Everything that you can do to prevent this regularly, you can do with inside SQL, this SQL instance, and then you get back a safe query that you can run. The third thing that would be nice to have would be raw strings. They were proposed for Java 12. There was a JEP for that. That was withdrawn like very late in the process because it was overly complex, because it did try to do all of these things at once somehow, and that didn't work really well. I personally think it will still be kind of convenient to have raw strings in some form. So if you look at regex, those are always very confusing, and particularly in Java, it's very horrible because you have all these double backslashes, right? That's why IDEs like IntelliJ, not sure whether others do this as well, but at least IntelliJ actually tells you, you know, if I can mark this as a regex and I can show it to you as if it were a regular regex, which makes it, well, it's still unreadable because it's a regex, but it's less unreadable. So some way to say, I want a raw string, meaning there is no escape syntax. Like there is no backslash something means anything. No, backslash n is just a backslash character and an n character. That would be a raw string. I think that would still be convenient, and we maybe get it in the future, but there are no plans at the moment. So as a summary on the string part, Java strings are essential to development. We use them all day, every day, but they're not very expressive. And Project Amber introduces new features that tackle that. They make strings more expressive, but they did learn from other languages. They force us through a template processor, because then the convenient version of just having your SQL injection attack by, you know, creating a string of SQL, that is not the most convenient thing to do. It's just as convenient to not use str, but to use the actual SQL thing that you're supposed to use, right? So this forcing of a template processor is a learning from other languages to make sure that we use that the probably wrong way is not the most convenient way. And those things can be combined. You need a text block, yes or no. You need interpolation, yes or no. You need raw strings when they come, yes or no. If they come, there will also probably not be a new special kind of string, but some kind of modifier. Which concludes the first part on strings. Now let's talk about type safety and encapsulation. So by the way, if you have any questions, if you trust yourself to yell loudly enough, you can just raise your hand and then you can just yell now, or you can find me after the talk here or throughout the rest of the day at the conference, but I have to leave tomorrow morning, so I won't be here later. Find me today if you want to have any questions. Okay, let's talk about type safety and encapsulation and how Project Amber tackles the tension between, you know, we want to have type safety, we want to have encapsulation because they're meaningful and important building blocks in the way we solve problems, but sometimes they get in the way and make code more cumbersome than it feels like it has to be. So Java is strongly typed. That means every field, every variable, every method return type, all of that has a specific type. And it's statically typed. All those types are known at compile time. And something else that we often do, as I said, is encapsulation for the types. And, you know, what we create, we consider visibility modifiers. We try to decouple the API from the internal state to hide the internals. So hopefully you all do that as well, right? You start with the lowest feasible, you pick the lowest feasible visibility, meaning you start probably with private, and then you realize, oh, I don't know, some other class in the same package needs to see it. Then you upgrade to package visibility, or from some other package, somebody needs to see this. Does this actually make sense? And if yes, upgrade to public. Right, and we rely on type safety and encapsulation, at least I as a Java developer, all day, every day. And actually, when I started writing JavaScript, that was by far the biggest challenge to me. Not the idiosyncrasies of the JavaScript language, but when I saw code and I got something that was called a user that I could not look up, what type is that? What do I have here? Does it have a name? Does it have a birthday? What's going on here? It was because that was just not my way of thinking. That was very challenging for me. Because we rely on them to model domains, to guarantee invariance, right? A encapsulated class guarantees the invariance within it. We modularize problems. We catch errors early and we understand code that way. But they can get in the way. They can be verbose and they can feel redundant. And this tension is something that Project Amber tackles. But it's not the first thing to try that. If you think back to lambdas, you will see that what you do here with the arrow, person, arrow, blah, 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 that code, that isn't fundamentally new. Yes, the predicate person on the left-hand side, yes, the arrow on the right-hand side is new, but the predicate person on the left-hand side, you could have created that in the past if it existed. You just have to write an anonymous implementation of the interface predicate. That's not one line. Depending on code formatting, that's like 5 to 7 lines. So nobody wants to do that, right? Imagine writing a stream pipeline without lambdas. It works, it just looks horrible. So lambdas did not allow anything new, really. What they did was they focused on the essentials. They said, okay, what this is about the behavior, and it's about the semantics of the variables that you're using. And so it focused in on just that, and everything else was stripped away. All it did was to find, in this specific situation, a much better balance between the verbosity and the safety. And that way we get more code as data, because now it's more feasible to do that. So again, type safety encapsulation in this specific situation came like a little bit in the way. So this new feature carved out an exception. And Project Amber aims to do more of that. We give a small amount of benefits in very specific situations where this trade-off does make sense and does not harm us too much. And then we get new semantics, new features, and less verbosity for that in exchange. For example, var. var was introduced in Java 10. And now you can write var audience member is a new person instead of person audience member is a new person. Or worse, person is a new person. Again, we can focus on what's essential, which is the variable name and the expression. In fact, I challenge you, when you're creating a person, well, you can write var or person, whatever you prefer, but I challenge you not to write person here, because that's already the type. The type lives in the entire package, or maybe in the entire application, maybe even the entire JDK. Find something more specific that describes why this person is relevant in this specific context. And I think var helped with that, because they strip away this information that, oh yeah, it's a person. Again, it removes verbosity and redundancy, and it finds a better balance to make code a little bit more readable. But this one, I think, is the most arguable of the bunch of features that I show you, because I know that many people are not so much in favor of using var, not using var a whole lot. I think this is the most defensive way to use var, to use it where the right-hand side is a constructor, because then the type is already always there on the right-hand side. And you can then gradually expand your use from there if you feel like it. Okay, so Java 16 introduced records. Records are transparent carriers for immutable data, and both of those aspects are important. The fields they have are final, so they cannot be reassigned. That's the immutable part. And they are transparent because the API is always bound to their internal state. You cannot hide anything. You cannot say this, oh, this field is I'm not going to show that externally. I'm not going to give an accessor for that. That doesn't work. Which is good if you don't need that. If you don't need the encapsulation, if you don't need the immutability, this gives you a lot of features. It reduces verbosity a lot. And now we can more easily encode data as data with records. But records go further, and for that, I want to make a quick detour into pattern matching. We're going to come back to records in a second. So since Java 16, you can use if something is an instance of another type, and then you append a name for a variable. And if object is indeed an instance of person, you get a new variable named person of type person that you can then use down here. That's pattern matching in if. In a nutshell, what this basically does is like this 3 steps of doing the test, if object is instance of person, then declare a new variable called person of the type person, and then cast into that variable. Those 3 steps are done in one here. And we can also apply this in a switch. Again, that works since Java 1. So you can switch over an object, and then you can say in case is this type, give me a variable of that type, and then I do something with it, and so on and so forth. You can do this since Java 21, which I'm talking about this as if it were in the past. The reason is A, that Java 21 feature set is now final, so nothing's going to change there anymore. And B, I don't have to update the slides in a few months, at least not this one. So what I can do as well is I can say if the object is an instance of person, and then I take the person apart into its 2 constituent members. And that works because when I created the person record, I gave up encapsulation. I said, like, I don't care that I can hide internals. I don't want to hide internals. And that means that I'm giving the compiler and the language the ability to understand how to construct and how to deconstruct these instances. And you can do the same again in switch. So this is only possible because of the limitations of records and because of that trade-off that we made there. We're going to come back to that later. Very good question. So the question for those who didn't hear is, what if I just need the name? Do I also have to, list the birthday and everything? And the short answer is yes, for now. unless you want to use preview features, then already no. I'm going to come back to that later. This is on the horizon. Still like just behind the horizon, no, just in front of the horizon. Can you be in front? You know what I'm saying, right? So we can already see it, but it's very far away. So what we're doing is here, we're fetching a person, and we don't need the full person. We just need the name and the birthday. So what about this? This is speculative syntax. Nobody knows whether this is what it looks like. You might know this from JavaScript, where you can just destructure something on a call, right? You just call the thing, you get it back, and you just immediately take it apart because you don't care about the instance itself. It's coming links to a tweet by Brian Getz. So that's all the confirmation we have at the moment. Something else that we might get in the future, based on records, there's just a design document on that, is what I'm doing here. I'm fetching the person, and then I want to create a new person that is exactly like the old one, but it has one field changed. Just as a different name. But everything else should be identical. So here on the top, I'm doing this like the manual way, right? I'm fetching the person, and then I'm creating a new person which has the other name, but then lists the birthday and would list all the other ones. In August 2020, Brian Getz published a design document that foreshadows something like a with expression or a wither. Wither comes from like setter. So the idea here would be, because again, the language knows what the record is, what it looks like, how to take it apart safely, how to reconstruct it. Person can be taken apart into name and birthday. Then you get two variables in this block that are name and birthday that are set to the values that this person had as a name and a birthday. Then you just overwrite the ones you want to overwrite, and at the end of that with expression, the new person is constructed, and you get back the unnamed person. Now I'm not only showing you this so you go, oh, and about all these cool features. I want to show you how it can be helpful to give up certain things that we're used to in a specific situation so that we can get back more, like with lambdas where we got succinctness, which was direly needed if you want to use something like stream APIs. But also in this case, because that the language understands record, just gives it way more power to help us interact with those instances. So as a summary, type safety and encapsulation are the bedrock of Java development, and we will still use them in like 80% of our code, but they aren't free. They're not the neutral choice. They come with trade-offs and with costs. And Project Ember tries to introduces new feature that lower that cost, and that way make them shine even more. For example, records make it so easy to create types that you're very likely to create more types than you did in the past just because it becomes a one-liner. Just how the strategy pattern that used to be like a whole thing that you can gloat with in an interview in the past is just now passing a lambda. You're doing it so often you don't even think about it anymore. Okay, now let's get to the biggest one about dealing with data and treating data as data. If you want to deal with data a lot, you're getting JSON, you're fiddling around a little bit with that, you're passing that on to some other system, you get SQL results, maybe you're processing events. All of those are situations where you're not necessarily needing like the whole machinery of an object-oriented object graph. You just get glorified strings and you want to play around a little with them and then pass them on. And if you want to do that, ways that really help making this maintainable and effective for you to write code is to represent data with simple immutable types. You want to be able to model alternatives explicitly. You want to somehow be able to encode that the user either has this kind of address, or for example, the user either has to give a phone number or an email address for confirmation. These are very different things, but you need one of those. You need some kind of confirmation mechanism. One of those two is enough, though. You want to make illegal states unrepresentable. You want to make sure that you don't load stuff and represent something that's illegal and then hopefully deal with it right later. But ideally, you cannot even create the thing that's not supposed to happen. You want to represent polymorphic behavior with functions. I'm going to get back to that in a second, like to all of those actually. And you want to be able to deconstruct data easily and quickly. So let's look a little bit over this. I have an example, which is a GitHub crawler. It does something very simple. You give it a URL, preferably a GitHub URL, then it works best. And then it just tries to identify the interesting part on the GitHub page, like for example, the conversation in a comment, on a pull request, on a ticket. Tries to find those links and then follow those links. And if that's a GitHub page, do the same process again. It builds a little page tree. Technically, pages can refer back to their cycles, so they're not really a tree, but we ignore that for simplicity's sake. And all of that code works and exists in this method called load page tree. We do not care how that works. So let's only look at what page. That's the type we get back here. What does page look like? Let's go through these things that I mentioned earlier, through these pieces of advice. We want to represent data with simple immutable types. Records make that very easy. What possible states could we have if we contact this, if we let this the system do its work? Well, we could have an error page, right? If a link was dead or the server was down or whatever. We could have successfully connected to the page, but it was not actually a GitHub page. Or it could be one of the 2 GitHub pages that we understand. Again, for simplicity's sake, let's imagine that GitHub only had these 2 kinds of pages. So now we just very simply represented the data with simple immutable types. This is straightforward to read, straightforward to write, and straightforward to deal with. But let's also model alternatives. That was the other piece of advice. And we do that with sealed types which limit inheritance. Let's go back. Let's talk about limiting inheritance for a second first. If you create an interface, let's only talk about interfaces. This also works for abstract classes and classes, but it's slightly different. So it's easiest to talk about this on the level of interfaces. If you create an interface, you have 2 choices for who can implement that. Everybody in the same package or everybody in the same, well, okay, module, 3 choices. Or everybody in the same VM, right? Those are your 3 choices. That is not a lot. There's a lot of everybody in there. If you have classes, you can do something like package visible constructors. You get a little more choice, but still there's no way for you to distinctly select the ones that implement a type. And sealed types allow you to do that. So here I have a public interface page, but I sealed the interface. That means I only permit specific types to extend it. Only error page and successful page can say that they extend or implement page. Any other type who does that? Like at the bottom, I'm trying to say my page extends page. Nope. Compiler says, look, you told me that page only can have these 2 implementations. My page is not part of that, so you can't do that. That's a compiler error. At first glance, this looks pointless. Why would I make my life harder? Now I have to, when I create my page, I have to go back to the sealed interface and add my page. And this is not something that you're going to do everywhere. Probably it's going to be something that you do only in very specific situations. Most interfaces are meant to have as many implementations as make sense. Nobody needs to know what the experimentations are, and that's all good. But there are situations that are different, and for those situations, sealed types are great. Because we can use those 2 model alternatives. We can say, well, a page either is a successful page or an error page. If it's an error page, if it's a successful page, it's either an external page or it's a GitHub page. And if it's a GitHub page, it's either a pull request or GitHub or pull request or issue page. So if we take these sealed interfaces and the records we created earlier and put them into this diagram, we get this, which in, I'm pretty sure, standard UML fashion uses blue for interfaces and orange for records. So the hierarchy I created here shows that, you have the page and the successful page and the error page and all those types here. The interesting part is that from the top down, since every interface is sealed and every record, I didn't mention that, is implicitly final, we know that when we have a page, it must be one of those other types. There's just no other option. A page must eventually be an error page, an external page, or one of the 2 GitHub pages. It cannot be anything else. It's just not possible. And this limitation comes in extremely handy when we try to make illegal states unrepresentable. Other situations too, but these 2. Because if you combine this, you can create records that are very specific to the data points that you want to model. And if there's a situation where it's either this or that, you just create a type for this and another type for that, and then you create a this or that type that is sealed that only allows these 2 implementations. And everything else that you want to do beyond that, you do data validation in the constructor. That means many things. So for example, I said earlier, you need either an email address or a phone number. If both of those are fields in the same type, you could maybe create a type which has neither field, so both are set to null. In this case, it probably would make sense to, it would be okay to have both. But if that is not okay in the domain, then you would also have to build checks or static factory methods or whatever that prevents that you can set both. If you have several of those things, you get into combinatorial explosion where you have 2 options here and 2 options there and 2 options there. That's just 8 constructors. But what this also does is it makes the code more self-explanatory. If you want to see what a page can be, you just look at the type hierarchy And it tells you what a page can be. There is no weird combination of fields that is legal and another that is not legal. But it becomes way more, like even more important and interesting later. Because now we want to represent behavior. We want to represent polymorphic behavior with functions. So, first, why? Why are these not simple methods? If you have types that are very integral to your domain, you often have very different systems operating on them. And if the type has one method to, create a bill, and another method to, send some order to the user, and some other to send them birthday wishes, you suddenly have colliding the same type, the billing system, the order system, the calendar system, and that's not fun, right? So we try to avoid that. And one way to avoid that is, for example, with a visitor pattern, to not put the functionality on the type, but to put the functionality elsewhere, and then just, pass the type in. You can do this, for example, with a static method like this. What I mean by polymorphic is different shapes of data, or usually use polymorphism in the context of objects, different shapes of objects need to be treated differently. This kind of object works different from that one. So for example, list.size has the same behavior, but ArrayList.size is implemented differently from linked-list.size. So their behavior internally is different, even though they implement the same API. So, but how will we do this, right? So it's pretty easy to write a method that gets, or static method, so let's call this a function for now, that gets a page as input. But how do you deal with different kinds of pages? This is where the switch that I showed you earlier comes back in. So we can switch over the page and kind of say, well, if it's an error page, we do this. If it's an external page, we do that. If it's a GitHub issue page, and so on and so forth. So this uses several new-ish language features. This uses switch as an expression. So I write return switch, because the switch gets its own value. That's since Java 14, I think. And then here we have the case statements that match error page and say, okay, if it's page is indeed an error page, I get a new variable ERR. And then I map, basically, the input to this output. So for the error page, the output will be boom, error, and then the host of the URL. Okay, let's now fold in something that we learned earlier, which is the sealed types. What you want to do is you want to switch over sealed types. It's the ideal case, and it really makes sense to strive for that as much as possible. You want to enumerate all possible types, and then you want to avoid the default branch. Because what I showed here is I put some 3 dots here at the bottom. I was like, well, maybe we have to put something here, but we don't actually have to put anything there. This works. And this works because the compiler understands that if you have a page, it must be one of those 4 types. There is no option that there's a 5th type in play. It's not. So this compiles. If you would remove the case GitHub PR page line, it would not compile. Because page, not all possible instances of page are covered. And that means that the compiler helps you make sure that these polymorphic functions actually deal with all input data. And if the input data changes and you do add a 5th, let's say, I'm going to go through that example later actually, a GitHub commit page, then you cannot accidentally have undesired or even undefined behavior. We can also apply deconstruction here that we learned earlier. So I don't really need the whole error, right? The whole error page. I just need the URL. So we can take the error page apart into URL and the exception. The exception is not needed, which is Down here, it's even way worse. We just need the issue number and URL, content, links. That's all not needed. That's it's not fun. Like if you write this code, it feels stupid to do it, and it adds a lot of unimportant information. It just makes it harder to read, which is not great. So Java 21 previews unnamed patterns. Unnamed patterns are the single underscore, and you can use that in place of a pattern when you don't need that variable. So now you have this. This helps you focus on what's essential, and I'm claiming that this is, once you get used to the syntax, extremely readable. It says, okay, so I need to create the page name. I'm getting a page that I'm switching over, and if it's an error page, I only need the URL, and then I build this string. And if it's a pull request, an issue page, I only need the issue number, and then I build this string. And we can further use the single underscore to define default behavior. I said earlier that we need to avoid the default branch, or that we should avoid the default branch for this functionality. This is when you would do that, or how you would do that with the underscore. So I want to create a page emoji, but only the GitHub pages have an emoji. All the other pages don't. So it's very inviting to write default and then NA. But if you do that and you add a fifth page, the GitHub commit page, then suddenly the GitHub commit page falls into the default branch. And that's not what we want, right? So if you do it like this, we add the GitHub commit page, we get a compile error. The compile error neatly leads us here, and then we have to figure out what to do here. So data-oriented programming uses Java's strong typing to model data as data. The recommendation is to use types, particularly records, to model data as data, and seal types to model alternatives, and then to use static functions to model behavior. Specifically, you want to do exhaustive switches without default branches, and then you want to use pattern matching to deconstruct data so it becomes easy to deal with. This looks a lot like functional programming. It's pretty close. It's not quite that. It's very similar. Both of them focus on treating data and functions separately, or modeling them separately, and then letting them work with one another. Functional programming, everything's a function. You focus more on making functions work together. Whereas in data-oriented programming, if push comes to shove and you have to make such a decision, you're sticking closer to, okay, what's the data really look like? And then maybe you write the function around that. But if object-oriented programming is here and functional programming is here, then data-oriented programming is more like here somewhere, right? It's more close, definitely closer to functional programming. But this also doesn't mean that object-oriented programming is dead now. That has been declared dead very often. It's still not dead though. We still want to use object-oriented programming probably as Java developers, because people have been using functional programming concepts for forever to solve similar issues. But we as Java developers, to what we're used to and what the language gives us as tools, we still probably want to modularize large systems to smaller subproblems with object-oriented programming, with creating modular solutions to subproblems and whittle the problem down to something that you can focus on without having to know all the rest of the system. But at some point, the problem becomes small enough that you can really understand the whole problem at once. Or it becomes very data focused. And those situations, it really makes sense to use this data-oriented programming approach. I gotta say, since that thing is out there, I don't write software that runs in production for many people at the moment, being a developer advocate. But I create a lot of small projects, something for a demo, some internal tool that we need. I sometimes write my own stuff just for as a hobby project or because I need some automation on my own system. And all of these are smaller systems, so I understand that data-oriented programming would be overrepresented there. But I keep using it all the time. In every project that I have been working on last year, every time I end up with that structure. I don't aim for it. It's just oh yeah, this is a record and this is a record. Oh, it's either or. Let's use a seal type. Oops, we have a function here. Let's destructure. It just works really, really well. If you're interested to learn more about this, Brian Getz wrote a great article on InfoQ. The GitHub crawler that I showed you is implemented. It's in a project called Loom Lab because you use virtual threads to connect to GitHub, which is really cool. And on the YouTube Java channel, on the Java YouTube channel probably, there are some videos on this topic. All of these are links, but if you type these things into Google, you'll also find them. Let's quickly have a look at what. Okay, I've got a few more minutes. That's great. So object-oriented programming is still the beating heart of Java development. It's not going anywhere. It's still the best fit in many situations, but Project Ember introduces new features that unlocks in Java, new programming paradigm, and also makes functional programming more feasible at the same time. Let's talk about starting with Java and how Project Ember wants to pave the on-ramp for new developers that are either just new in general or at least new to Java. So why do we care? We all know all of this, right? We all know IDEs, Java, we know all the build tools, all that stuff. First of all, I want to claim that maybe we don't really. In every conference, there are people who are a little bit newer. But I've used Gradle, but I still will not claim I understand it. I've never used Bazel. I just heard of those. So I think for most of us, it's still true that we know maybe one or two alternatives in many spaces. Maybe we've never dealt with problem X, Y, Z, and so we don't even know what solutions exist there. So I actually claim that we do not all know everything. But you know what? If you want to show your kids some Java, do you want to start with Maven? What about students that want to learn programming in high school or university? What about the front-end developer or data scientist or somebody else who is already an experienced and gifted programmer but wants to switch over to Java? Can we expect them to first learn huge amount of tool chains and everything? What about the MLAI folks, which are currently a big chunk of the the development market, so to speak, meaning like a big chunk of development happens in that space. Wouldn't be too bad if they would also, maybe give Java a try. So Java does need to be approachable. Java needs a way for new developers to get started without having to, well, first thing you install IntelliJ and Maven, and then all of those steps. So let's see how much of that is really needed. To write and run a simple Java program, you need, well, JDK obviously. You need an editor for which you can use the IDE. You can use Java. You need to use Java C somewhere or other. Again, the IDE can help, or the build tool. You need to use Java to execute. The IDE can do that again, and you need to write some Java code. Now, IDE pops up a lot there, so it looks like the solution. But I still remember what I first thought when I opened Eclipse, and this is not I'm not saying anything negative about Eclipse. It was just the first real IDE I used. For most people who have not already done something like maybe graphics design or video editing or something, the IDE would be by far the most complex program they ever open, right? So the IDE is not a solution to somebody who struggles with complexity. This is the minimal Java code that I need. What do I need to learn to really understand this? I need to understand what public is. I understand visibility. How do classes and methods work and how do they relate? What is static? And what is an instance? And it's really confusing to beginners. How do return values work? How do parameters work? What are statements? What are arguments? I need to know all of that to understand these 5 lines of code. Now, to somebody new, you could say, you know what? You actually don't really need the first 3.5 of those. Ignore all of that. But I claim that works, but it's not good. It's not good to give somebody who's curious and wants to learn the piece of advice that this is just some black magic that you have to do to get started. Again, it works, but it demoralizes them. And it means that they feel like they're wading through complexity that they don't understand. Or you can teach all of that in like a, short 8-hour course before they get to start to write their first program. So that's a lot of tools and concepts to learn. And those are good for large-scale development, right? The detailed toolchain, the programming model, they really help us to solve big problems with Java. But at the same time, this makes it less approachable. So let's change that. Let's try to find a way to ease people slowly into this choice of programming paradigms and tools and language features and all of that. JDK 9 added JShell. If you start up JShell, you can write your Java code right there. All you need for that is the JDK, and then you launch JShell, which is pretty simple. You need to know what statements and arguments are, which is very little and something you probably want to deal with anyway when you're programming. So that's actually pretty good. I would still claim, in my opinion, it's not great for beginners. I feel when I'm using JShell, I feel like it only works when I already 80% know what I'm doing. Like, it doesn't feel like a good way to experiment. Tab completion is terrible. There is no syntax highlighting. It's just not easy to use. But also there's no progression. Once I've done something successfully in JShell, how do I turn that into a program? Not really easily, if at all. So we need more. Java 11 added single file execution. Now you can just say Java and then a source file. That removes Java C, class files, bytecode, all of that is out the window now. So, or rather, it's like hiding behind the couch. But still, you don't need to know it, right? You can start much simpler. But there's no progression from there. You can start there, but you still, like, at some point, very soon, you need to do more things. So I think it's good, but it's just a section of the on-ramp. And so the on-ramp needs to expand the single file execution, I think, in 2 directions. Well, that's at least the way I view it. It needs to make the Java code that I need to pour into that single file even simpler. And we need to have a more gradual increase in complexity instead of single file works great. You want to have a second file? Now you need Maven and an IDE. And again, I don't want to, I'm not saying that I don't want to bash Maven or Gradle or all these IDEs. They're great tools for us. It's just challenging for beginners to start using them. So, okay, for the simpler code, there's actually a proposal here. We can remove the args parameter or make it optional. We can remove the necessity of main being static. Main doesn't have to be public. The class itself can go away, and suddenly I can write this. Void main system of print and hello world. That's all the code I need. And in Java 21, if you enable preview features, this compiles and runs. No applause? Okay. It's not my work, so I can applaud on the mailing list for the people who did this. No, I was going to say, I think this is really spectacular. I think this really makes Java so much easier for people to start. But I got to say, I occasionally write a script in Java. I'm not ashamed to do it. And this makes my life easier too. Or just like a little demo of like, how does that feature work again? It's just so much simpler. The other part is, and there's a JEP draft for that, is to allow you to run this simple way of Java and then the file with more than just a single source file. So I have a folder, my first Java, and I have a proc Java and a helper Java, and maybe even, some libraries in there. I will probably in the future be able to just run that with one command as well. So now you're in a situation where you start with just a simple main method, and if you need arguments, well, then you need to learn. Then you can learn about string bracket args, which is great because you have a use case, you want it, and then somebody gives you a solution, which is just a great step. I think I'm about to be dragged off stage. Yeah, 2 more minutes. If you need to organize code, you can start adding methods. If you need to share state, now's the time to learn about fields. Oh, you want more functionality? Look, the JDK has more of these APIs. If you need even more, maybe it's time to include a library. And if you need more structure, now you can split it into multiple files. If you need even more, you can use visibility and packages. And if then eventually you want to ship something, then you need to do the step to a build tool. And the cool thing about this, you don't need to do this in that order. So you can start with a simple main, and pretty much every problem you have, whichever of these it is first, you can get to the solution and you can start using that. So Java's strengths for large-scale development make it less approachable, but the detailed toolchain, the refined programming model, those are strengths for us, but weaknesses for other people. And Project Amber tried to make them not required when you get started, so that the future developer generation is actually enticed to use Java for their stuff. Okay, so now there's a summary, but it's just these features were up in 21, up to 20. These are in 21. Then there's stuff beyond that we talked about, deconstruction assignments and with expressions. And then there's even more stuff that we didn't even have time to get around to. So clearly, Project Amber is working on a lot, and it's really the solution factory to Java's problems. Thank you very much.